Today in this lecture we are going to talk about the general math strategies. These strategies are basically designed to help you ace your maths section on the GRE. Now, as you all know from our previous lectures, that the math section has 30 questions in total. Each section has 30 questions in total, and you have 35 minutes to solve them. So if you calculate, you have approximately let's say 1 minute and 10 seconds for each question. But there would be certain questions that would, let's say, may take you 40 seconds, and there would be many questions that may take you as long as maybe, let's say, 2 minutes and 20 seconds. So your task is to basically do each and every question as quickly as possible. Remember, the questions themselves may not be that difficult, but if you don't know the right techniques to solve the questions, you're going to waste a lot of your time. And by the end of the section, you may have, by the end of the time of a certain section, you may have solved many questions correctly, but you may also have wasted a lot of time. And finally, what happens is that students end up, leaving 4, 5, 6, maybe 7 questions at the end. So that's not something that you want. So let's see how you can basically improve your time on the quantitative section. So one thing is that you don't want to get the on-screen calculator on the GRE every time you encounter a mathematics question. So we have this bad habit, all of us, that whenever we see a maths question, we always resort to a calculator. So you get a calculator, but it is a mistake, remember, to reach for it more than once or twice during a quant section. There would be hardly 2 to 3 questions on every section that would basically necessitate for you to basically go for the calculator. So if during the practice, if you're constantly approaching your calculator for basic calculations, that means that you're practicing your quantitative section in the wrong way. I've already said that the questions on the GRE, they're not very difficult. However, they require a lot of mental math. So let's move forward and see how that could be done. You see, GRE Quant is specifically designed to punish folks who are always reaching for the calculator. Now, this is very, very true. The GRE is specifically designed to punish those people who always resort to calculator whenever they see a maths question. If frequent use of the calculator is a big part of your GRE quant plan, you are going to fail right into their trap. So remember that it's a trap. In fact, during the older days when the GRE did not have a calculator, people always longed for it. People always demanded that there should be a calculator for it. So now the GRE has, in this newer section, in this newer version of the GRE, they have added the calculator. However, remember that it's a trap. So if you're constantly using the calculator on the GRE, so that's something that you shouldn't do. All right. And why is that a trap? Because the GRE quant is not a test of your ability to perform complicated and detailed calculations. So GRE would never ask you to basically multiply, let's say, 211,575 multiplied by 373. Okay, so this is a very long calculation, and definitely to solve it correctly and quickly, you would need a calculator. But the GRE would never ever throw a question like this to you. Now, while solving a question, if you encounter a certain expression that gives you something like this, remember, you always need to basically estimate. And in the later videos, I'll talk about how to basically estimate these values. But don't ever think that GRE actually wants you to basically calculate this value. So let's move on. Instead, the GRE is interested in testing your mathematical logic. So that's what they're interested in. Remember, the GRE is an aptitude test. It's an intelligence test. So anybody can plug in these numbers in the calculator and they can get the answer or solution. So that's not the point of an intelligence question or an aptitude of an intelligence test or an aptitude test. So Remember that it's a mathematical logic, it's your mathematical logic that the GRE is testing. Many GRE problems appear to require a detailed calculation, but when you use logic, you'll realize that a simple or a very simple, elegant solution is possible. And in later half of this video, we'll see that how that's done. It's very important to be comfortable with basic mental math. So that won't be happening if during practice you keep on approaching your calculator every now and then. So during practice sections, always leave your calculator in your drawer. Never take out your calculator unless and until you think that it's absolutely necessary. Practice doing as much mental math as possible without a calculator. So in your daily life, when you're calculating something, when you're adding or subtracting or even multiply certain things, always try to estimate, at least estimate the numbers. Force yourself to do mental math every day. Add, subtract, multiply and divide in your head. So mental math is something that is not going to basically only happen when you're practicing for the GRE. You have to apply in your daily life. Do everyday math in your head every day. Calculate tips, sum your grocery orders as you shop, estimate the gas mileage of your car, etc. So all of these are basically estimates. And you should be comfortable with your mental math. So let's talk about estimation. Now remember that not every number could be estimated, but normally when the people at GRE or ETS, when they make questions for mathematics, they always give you numbers, or in most of the cases at least, they give you numbers that are easy to estimate. So one of the big ideas of mental math on the GRE is estimation. You can use calculator, but again, as I've said before, that it would be a waste of your precious time if you reach for your calculator every now and then. The GRE does not care about your ability to perform detailed calculation. You should keep this thing in mind. It cares about your ability to simplify. So this is what they're looking for. That can you simplify a complex problem into simple steps? So if you can do that, they think that you're ready for moving towards your graduate studies. So let's think about it. So as you can see that we have a very, I wouldn't say a very complex problem, but some complex numbers. We have a decimal percentage, which is 26.3%, and then we have a number which is 7,935, and they want us to basically calculate it. So you have to basically multiply 26.3% with 7,935. Now you can clearly see that to get an exact answer, you would need a calculator. I mean, I'm not that good I don't have those good mental math skills to basically solve this question exactly. But one thing you should notice is that look at the options A, B, C, D, and E. So option A is 1592 approximately, option B is 2086, option C is 2800, 3400, 4100, and some change. Now one thing to notice here is that there's a significant gap between all the options. There's approximately a gap of 500 here between A and B, a gap of approximately 800 between B and C, a gap of approximately again 800 between or 600 between C and D, and once again a gap of 600 to 700 between D and E. Which means what? Which means that you could trim these numbers. So how could we trim these numbers? So 26 is closest to, let's say, 25%. Why we are interested in 25? Why didn't we take it down all the way to 20? Because that would be a huge jump. That would be a huge decrease that we don't want. For estimations, you want small changes into your numbers. Another reason why we jumped down to 25 was because 25 is equivalent to, in terms of fraction, it is equivalent to 1/4. Alright. So now you want 1/4 of 7,935. Once again, this is not a very straightforward number. So you can basically increase this number to, let's say, 8,000. Now you can understand that this is a very simple problem. You have taken this complex multiplication and you have turned this into a simple multiplication. So what happens is that if you want to find the solution to this, it's very easy. That's 2000. Now, definitely you'll say that, okay, we don't see 2000 in these options, but what is the closest number that you see in these options? And that is clearly option B. And if you take out if I take out my calculator, and let's say if I feed in this number, which is 26.3 multiplied by 7,935 divided by 100, and I get 2086.905, which is exactly option B. But I didn't have to do or didn't have to use my calculator. I very easily simplified this complex multiplication into a very simple looking expression, and then I solved it without using any calculator. You might also be thinking that, okay, maybe it's easier or faster to basically do this on the calculator. But that's not the case. If you're basically every now and then, if you're basically going to your calculator and grabbing your mouse and feeding in numbers through mouse, or maybe even the numeric keypad, it takes some time. When you are comfortable with simplifying these complex numbers into these simple expressions, trust me, with practice, you can get really fast at doing these simplifications. So I highly recommend that while you're practicing for your maths, you should basically rely less on your calculator and more on your mental math skills. Okay, so it's the same solution. Let's move on. So we have another problem. At Gigamart, tiles cost $4.25 each. What is the total cost to buy 484 tiles? So once again, you can see now again you will never get a question as easy as this on the GRE, but it's highly probable that to solve a question properly, you may have to basically solve this expression. So to do that, once again, first thing for estimation, it's very important. First thing that you should notice is that the gaps between all the options is once again pretty large. So there's a pretty huge difference between 113 and 205. The same goes for 205 and 1100. Once again goes for 1100 and 2000 and 2000 and 11,000. So there are huge gaps between these numbers. So if you basically moderately reduce or increase these numbers, it's not going to basically impact so much on the final result. So you can see that we can reduce this number to 4. We could have taken it to basically 5, but that would have been a greater jump. So we want smaller jumps. So we won't do that. We would reduce it to 4, and we would increase 484 by 500. And that's easy. That's 2000. And what is the closest option? That's option D. So one thing to notice is that you should always check the answer choices before estimation. If the answer choices were, let's say, if your answer choices were, let's say, A, 2000, B, 2010, C, 2020, D, 2030, and E, 2000 and let's say 50 or 57. All right. Now see, the gaps between these options is really small. So here I wouldn't be as comfortable with my estimations as I am with these options. And most of the cases you will get, options that are significantly different from each other. But to be on the safe side, you should always look at the options first and see if before estimation that whether the gap between all the options is significant enough for estimation. All right, let's move on. So if a GRE quant problem seems to call for a lengthy and complicated calculation, think again. So this is something that you'll basically start noticing while you're into your GRE quantitative practice, that every time you're solving your question, whether it's arithmetic or algebra, and you're going into your expressions and your equations are expanding. So you should always stop and and understand that you have fallen into a very typical, a very common GRE trap. The GRE never ever wants you to basically solve very lengthy, huge equations. So stop, take a deep breath, think about the question, think out of the box about how you can solve it or how you can simplify that expression, and then basically try to approach the question again with the simplified form. The GRE is not interested in your ability to perform long calculations, so if a problem appears to demand one, there must be another shorter way to solve. That's very important. Estimation is often one way to solve, especially if the answers are spaced far apart. This is already clarified. Okay, so let's take another example. Okay, so in this question, what do we have? So at 10 p.m., a large building's water tank contained 211,358 gallons. Now, just by looking at this number, it should strike you that you have to basically estimate. Through the night, pumps increased this amount by 30%. Now, this is a very neat percentage, 30% by 5 a.m. The morning water usage consumed 5% of this 5 a.m. amount. How many gallons were consumed in the morning? So let's write our data. So the tank contained, or the tank capacity was, the tank cap was, let's call it the tank cap, it was 211,358 gallons. All right. And through the night, pumps increased this amount by 30%. Now, before taking 30% or trying to calculate the 30% of this number, let's think about it. What's the first thing that we should do? Look at your options. Are they fairly, apart from each other? Yes. So there are some good, not very significant, but good, gaps between these numbers. So let's estimate this this tank cap, or let's round off this tank cap. So what is the best number that we could get here? Let's say that the estimated tank cap was approximately 200,000. All right, it's very important. So the tank cap is basically approximated. In fact, I should use this approximation sign. So now the tank cap is approximately 200,000 gallons. Through the input, pumps increased this amount by 30% by 5 p.m. So by 5 p.m., 5 a.m. So the pump increased this amount by 30%. Now, one easy way to calculate or add 30% to a certain amount, or X% to a certain amount, is to take that number first. So let's say we have to increase this number by 30%, since by 5 a.m. the pumps had basically increased the amount by 30%. So we'll take this number, which is 200,000, and we'll multiply it by, let's say if we multiply it by 1. So what happens? So we'll get 200,000. So which means that this 1 represents 100%. So for an additional 30%, what we'll do is we'll multiply, instead of 1, we'll multiply it by 1.3. So this 3 will give us an extra 30% in addition to the 200,000. So as a result, now again, it's very easy to add 30% to this 200,000. So what is basically 30% of 200,000? So if you have 200,000 and you multiply it by 30, so we know that the non-zero numbers would multiply to 3 times 2 is 6, and then we have 1, 2, 3, 4, 5, 6. 6 zeros, 1, 2, 3, 4, 5, 6. And since it's a percentage, it would be divided by 100. And when we cancel them out, so we'd be left with 60,000. So that means that we have to add 60,000 to the 200,000 figure. So this would become 260,000. So by 5 a.m., the tank held a total of 260,000 gallons of water. Fine. Let's move on. The morning water usage consumed 5% of this 5 a.m. So this is the 5 a.m. figure, and the morning consumption was 5% of this number. Okay, so consumption in morning, that's equal to, let's bring it here, that's equal to 5% of 260,000. So we can cut these numbers out, and now we'd be left with now one easy way to basically solve 5 multiplied by 2600 is the method of doubling and halving. So what you can do is you can double the number 5. Let's say, what is 2 times of 5? That is 10. And what is half of 2600? So half of 2600 is 1300. That's 1300. Alright, so now that's easy. Now your answer would be, and remember this is an approximation, 13,000. So which number is closest to 13,000? Well, that is basically this very number, option D. So you just saw that we quickly solved this question where we had some not so good looking numbers, not so simple numbers, but we made our basically calculations pretty simple by estimation. So this is how basically you have to solve your questions on the GRE quantitative section. Okay, let's move on. Alright, so let's see how you can easily divide numbers by 5. Now generally dividing number by 5 is easier, but we just saw in even in this example, when I was dividing this number by 5, I basically, what I did was I doubled this number and I halved the other number. So let's see formally that how do you basically divide, how you can make your division by 5 easy. So one small trick of mental math involves a quick way to divide a number by 5. Suppose we had to divide 630 by 5. Well, whatever our answer is, 630 is 5 times too big. Notice that if we double 630, that will be 10 times too big. Alright, so what does this mean? So it means that if you have to basically divide 630 by 5, so let's say if this were the question, or this is needed to basically solve a question. So now what can you do? Now if you think about it, one easy way to basically solve this is to basically multiply the numerator and denominator both by 2. So how does that happen? So when you multiply both the numerator and the denominator by 2, so we'll deal with the numerator later, but let's think about the denominator. In denominator you get 10, and we know that multiplying or dividing by 10 is very easy. That's why we are basically, in terms of 5, we are basically doubling it, and at the same time we have to double basically the numerator as well. So what do we get from this? It's 1260. So eventually what do we get? 126. Once again, this might seem like a very unintuitive way of solving this, but once you get a hang of it, once you get practice and you are basically comfortable with this method, it becomes very, very swift. All right, so let's move on. Let's practice some of these numbers. So let's divide 235 by 5. So let's see how it's done. Okay, so we have to divide 235 by 5. So that's easy. Take 235 divided by 5. Increase both the numerator and the denominator by a factor of 2. By a factor of 2 means 2 should be multiplied in the numerator as well as in the denominator. So we get 235. So 200 would become 400 and 35 would become 70, and 5 times 2 is 10, so our answer is 47. See, that was easy. Similarly, let's take a bigger number, 1140 divided by 5. So 1100 when doubled would become 2200, 40 would become 80, the denominator we have 10, and our answer would be 228. Now pause the video and try question number 3 and question number 4 yourself and see what you get. Alright, so I'm assuming that you have tried these 2 questions, so let's move on. Alright, so let's talk about doubling and halving, something that I did in my last question. So let's see how does this logic works. So the logic of the dividing by 5 trick is just some much general and more widely applicable trick. Suppose we need to multiply 16 and 35. So in the previous examples we were basically dividing a number by 5. Here we have to basically, let's say, multiply 2 numbers, and it's not necessary that one of them be a 5 or a multiple of 5. They could be any 2 numbers. However, this trick works properly if one of the numbers is an even number, at least. Alright, so think about what happened there. One factor lost a factor of 2 and the other factor gained a factor of 2. So with these 2 numbers, what we can do is that we can basically half one number and basically we can double the other number. Now how does that work? So think about it. So if you have 16 multiplied by 35, if you think about it, you can rewrite 16 as a factor of 2. Alright? And you can shift this factor of 2 over to the other side, or you could multiply this out with the other number. So here we would be left with 8, and when 2 is multiplied by 35 we get 70. So see, what happened was that 16 was halved while 35 was doubled. That's why we are calling this strategy doubling and halving. Alright, so let's try some questions. So as I said, that it's imperative that one of the questions is an even number. Why? Because you would want to basically halve the even number. An even number could be divided by 2, however the odd number cannot be evenly divided by 2. So let's halve the 260 and double 15. So when you halve 260 you get 130 multiplied by, and when you double the 15 you'll get 30. Now this is easy. You have to multiply 13 by 13, 13 with 13, keep these zeros in reserve, so you get 39. And now use these 2 zeros. We have 1 0 and 2 zeros, so 1 2, and your answer is 3900. Let's move on. We have basically 56 and 25. So when we halve 56 and we double 25, we get 28 multiplied by 50. Once again, we are going to put the 0 in reserve and multiply 28 by 5, and what we get is 40, 140, and our answer is 1400. Alright, now pause the video and basically try to solve this last question. Okay, so now I hope you must have tried this question. So when we halve the even number we get 12, and when we double the 75 we get 150, and the answer is pretty simple. So it's 12 times 15, if you remember your tables. So 15 times 12 is 180, and you add this final reserved 0 and your answer would be 1800. All right. So let's move on. Now, I guess this is the last part of this lecture, and it's about squaring shortcuts. So let's say if you have to square numbers. Now, it's very easy for us to square one single digit number, such as the square of 9 is 81, the square of 5 is 25. So we're all very comfortable with this. But what if basically you have to square a larger number? Now let's say again, if you have a number which is a multiple of 10, so it's very easy to square them. All you need to do is basically take that number. Let's say here we have 40 square. So you take the non-zero part of the number, which in this case is 4, you square it, so you'll get 16. 4 times 4 is 16. And since there's a power of 2 on this 0, so you put 2 0 with it. And here you have square of 40. Let's say if you were to basically find the square of 90, so you'll take the non-zero part, which in this case is 9, you square it, which becomes 81, and you add 2 zeros in front of it, and you'll get 8100. So squaring multiples of 10 is pretty easy, pretty intuitive. You can pause this video right here, and you can basically try to find out the answers to all of these questions. Alright, so let's move on. These are pretty simple and straightforward, so I won't be basically solving all of them for you. So let's move on. Now, what if we have numbers that are basically ending in 5? Now, this particular method, it only works for numbers which end in 5. So don't try to apply the same concept to other numbers. So let's see how to go about it. So what is the procedure to square a number ending in 5? Now, the first thing that you need to do is basically take the number ending in 5 and write its non-5 digit, which in this case is 7. Now you have to add 1 to it, which would make it 8. And then you need to basically multiply this 8 by this number. So it's pretty simple. You have this number 75. You take this number, think about, don't write it, think about what's the next number with an increment of 1, that's 8. And what's 8 by 7? That's 56. And then simply add, or basically put the square of the 5, which is 25, with it, and you have your square of 75. Let's try this with 85 square. So we have an 8, increment this 8 by 1, we get, let's write it here, 9. We have to multiply 9 by 8, which is 72, and then we have to simply add 25 to it, and we have 7225. Okay, so this is pretty easy, right? All right, so let's practice this this method. I'll do let's say I'll do 25 and 115 squared, 25 squared and 115 squared. Then you can basically try 65 squared on your own. So let's take the number 2, all right, and increment it by 3, so that becomes 3 multiplied by 2, which is basically 6, and add 25 to it, and you get 625. That's easy, right? Similarly, take 11, increment it by 1, and you get 11 multiplied by 12. So we know that 11 times 10 is 110, and 11 times 12 is basically 132. So this is 132 with 25, and you have the square of 115 squared. So you can see that at least numbers that are multiples of 5, their squaring is very easy. Now pause the video and try 65 squared yourself. Alright, so in the future videos I'll be adding more techniques and that can help you in solving your questions on the quantitative section easily and quickly. Thank you.